Hello everyone, I hope you're doing well today. Today we're going to learn how to graph a quadratic function in vertex form. The vertex form of a quadratic function is f of x equals a times the quantity of x minus h squared plus k. To graph this function we're going to use 4 steps. Step 1 is to identify and draw our axis of symmetry, which is the line x equals h. Our next step is to identify and plot our vertex, or the point hk. Next, we'll make a table of values for our function, and finally we'll plot and connect the points from our table of values. So let's try looking at an example. Let's look at the function f of x equals the quantity of x minus 3 squared plus 2. To start off with, we'll find our axis of symmetry, the line x equals h. You'll notice that 3 is in the position of where our h is. So that means our axis of symmetry is the line x equals 3. Now that I've identified my axis of symmetry, I can also identify my vertex. I already know the x value of my vertex is 3. If I look, the second part of my vertex, the y value, is k. And in this case, 2 is where our k is. So our vertex is the point 3, 2. Once I've identified my vertex, I want to make a table of values to find and plot several other points. When you make your table of values, since a parabola is symmetrical, place your axis of symmetry, or your vertex, directly in the center of your table. Now to finish graphing making my table of values, I will only have to input 2 values of x to get my y values because of the symmetry. I want to choose 2 values that appear to the left and right of my vertex. So 2 values that are to the left of the vertex, or to the left of 3, would be 2 and 1, and to the right of 3 would be 4 and 5. If I input 2 into my function and evaluate f of 2, I would get 2 minus 3 squared plus 2. 2 minus 3 is negative 1, negative 1 squared is 1, and 1 plus 2 is 3. I know that if I input 4, I would also get an output of 3 as well because of the symmetry. Now if I input 1 and find f of 1, I get 1 minus 3 squared plus 2. 1 minus 3 is negative 2. Negative 2 squared is 4, and 4 plus 2 gives me 6. Because of the symmetry in the graph again, I also know that if I plugged in a value of 5, I would get an output of 6. Now that we've made our table of values, we can plot our points and connect them to create our U-shaped parabola. Once we have done this, we have finished graphing this function. Please take a moment to pause this video and record these steps and this example in your notes. Now let's try taking a look at another example. Here we have the function f of x equals negative 3 times the quantity of x plus 2 squared plus 8. Our first step, remember, is to identify our axis of symmetry, or the line x equals h. In vertex form, the equation f of x equals a times x minus h squared plus k. I'm always supposed to be subtracting h, but in our example we are adding h. If I see addition, then that means that I was really subtracting a negative. So in this case, since I see plus 2, my axis of symmetry is really the line x equals negative 2. If I see a plus inside the parentheses, again, remember that means I was subtracting a negative. Therefore, my axis of symmetry will be a negative value. Now that I have my axis of symmetry, I can find my vertex, which is the point HK. So I know my x value is -2. Looking at my function, my value for k is 8, so my vertex is the point -2, 8. Now I need to make my table of values. Remember when you create your table of values to put your vertex directly in the center, and then you can use symmetry to help you find other points. Since my vertex is at the point -2, 8, I want to choose two values of x that are to the right and to the left of -2. Two values to the right of -2 are -3 and -4, and two values to the right of -2 are -1 and 0. If I find f of -1, I would input -1 into my function, so I'd have -3 times -1 plus 2 squared plus 8. -1 plus 2 is 1, and 1 squared is 1. So I have -3 times 1 plus 8. -3 times 1 is -3, plus 8 gives me 5. Because of the symmetry, I know that -3 also has an output of 5. Next, I would find f of 0. When I input 0, I have the function -3 times 0 plus 2 squared plus 8. Starting inside the parentheses, 0 plus 2 is 2, and 2 squared is 4. So I have -3 times 4 plus 8. -3 times 4 is -12, plus 8 gives me a value of -4. So my input for -4 and 0 are both -4. Now that I have my table of values, I can plot my points and connect them to create my parabola. You may notice after graphing this function that our function is what's known as concave down or opening downwards. You can always tell if a function opens up or down based off of the value of a. Here our value of a is -3. If a is negative, the function is concave down, opening downwards. Going back to our first example, you would have noticed that a was an understood value of 1. 1 is a positive number. Since a was positive, our graph was concave up or opening upwards. Please take a moment to pause this video, record this example in your notes, as well as any questions that you may have. Take care, be well, stay safe, and I will see you in our Zoom meeting shortly.